So hi everyone. Actually, so in the continue of the channel length modulation, in the previous part, one thing I forget. So like that, the in case of the channel length modulation, if we increase the VDS more and more, the channel will be depleted. So like that, okay. So this is the effective channel length is there. This is the effective channel length. So we need to invert only this amount of the channel. So if we want to invert this amount of channel, so we need to apply the less VGS voltage on the gate terminal. Okay, so if we apply the less voltage, then we will get the VTH as some amount as the less VG. Okay, means we need to apply the less voltage, means the threshold voltage will decrease it. Okay, the threshold voltage will also decrease. So due to the channel length modulation, the threshold voltage will also decrease it. Because of that, if we apply the more and more VDS, due to that the penetration of the depletion layer will occur at the drain side like that. So due to that, the channel will start the depleted like that. Okay, so I show here in the figure. So this is the complete channel L minus delta. So we need to invert only this amount of the channel L minus delta L. So we need to apply less voltage on the gate terminal, means the threshold voltage will decrease it. Okay, and so here in this video I will see the second short channel effect. The short channel effect, that is the velocity saturation. Okay, so how the velocity saturation comes? Actually, this region comes under the under so this region comes between the linear region and the saturation region. Okay, so in between two region, so this region will occur. How I am telling? Okay, so one thing you already know, na. So suppose we have a, this is the wire is there, electric wire is there, and we are applying the some voltage on that. The electric field will be generated, that is the V by L. This electric field will be set up across this wire. Okay, the electric field is V by L. Okay, I think you know. No, see. So here we have a channel is there. The complete channel length is L. The channel length is L is there. Okay. Now, so if we apply the VDS voltage on the drain terminal, then the channel will start the depleted. But in this part, I will focus the velocity saturation. Means if we increase the VDS voltage, actually if we apply the VDS, so there will be a setup of electric field. Okay, electric field setup. Due to this electric field, it will attract the electron from the source terminal. This is the source and this is the drain. Okay, so here is the electron, negative terminal is there, electron, this is the electron. Okay, so if we apply the more VDS, then electron will attract from the source to drain and current will flow from the drain to source. Okay, so electron is going with some velocity from source to drain. That velocity is called, the electron will go from source to drain with some velocity. That velocity is called the drift velocity. Okay, that velocity is called the drift velocity. Okay, so if we increase the VDS further and further, so then the electron will go from source to the drain with more velocity, with more velocity. Okay, but the velocity will be, after some time it will be saturated. Why? Because of that, there is a, so this is the electric field. Okay, and this is the velocity. After some time, if we increase the VDS, means at the drain terminal, if VDS is increasing, means the electric field will be increasing at that side. So this is the electric field. Okay, so this is the electric field. If VDS is increasing, electric field is increasing. Due to electric field, the electron will get so more velocity to travel from the source to drain, means the velocity is also increasing, means velocity of the electron is also increasing. Means if further VDS will increase it, the further the electric field will increase it, and further the velocity of the electron will increase it. Because of that, electron will go from source to drain with high velocity, and the current will flow in the opposite direction from drain to source. But after some time this is not happened always. Okay, if we increase the if we increase more and more VDS, after some time the electric field will be saturated. If VDS will be more and more, then the electric field will be saturated. If electric field will be saturated, then the drift velocity of the charge carrier electron also saturated. That situation is called the drift velocity, and this practically is data linearly is increases. After that it will be saturated. That data is the 10 to the power 5 meter per second. Okay, this the electric field is called the critical electric field. The critical electric field. Okay, after this electric field, the velocity of electron will be saturated. Okay, this is called, so this is the velocity saturation. Okay, I am writing actually here. So this is the drift velocity expression is mu n into E. Okay, and the VDs and electric field which is developed across the channel. So that electric field is equal to E is equal to VD sat, means the saturated voltage divided by L. Okay, so here we can say no. If we apply the saturated voltage on that, the velocity will also saturated mu n and VD sat. That is the VD sat divided by L. So this is the velocity. This is the velocity. Okay, and and this is the saturated voltage. This is saturated voltage. Because of that, the electric field will go beyond that, the velocity of electron will saturated. Okay, so here we can calculate VD sat. VD sat is equal to the small, that is the velocity saturation, into L divided by mu n. Okay, so this region, velocity saturation region, will occur in between the source region and the drain region. So finally we can write the current equation like that. The mu n cox, the w by, so mu n cox w by L in vd sat. Okay, vd sat and vgs minus vth, vgs minus vth. Okay, vgs minus vth minus vd sat divided by 2. So when this region will come, actually VD sat means VDS, that is less than equal VGS minus VTH. Okay, so this is the region of the velocity saturation equation. This is the velocity saturation. If you want to write the current equation in the linear saturation region, Kn by 2, so no need to write. Okay, here I am writing just only this thing. So this is the equation of the velocity saturation. Okay, in case of, so this region will occur in between linear region and the saturation region. Okay, so if the VGS is less, if the VGS is less, like that, this is the actual saturation region is there, this is the linear region is there. Okay, linear region is, this is the VGS 11. If we apply the more VG, like that is it, this is the saturation, this is the linear. Okay, but if we increase the more VGS on that we will get like that. So here we will get the velocity saturation. Okay, velocity saturation. So you need to explain, and you need to write this expression. Okay, this is the so the velocity so the velocity the saturation region comes in between the linear and the triad region. I hope you understand this thing. Okay, and also one thing is there, if you want to write if you want to combine all the equation of the current, linear saturation and the velocity saturation, for that purpose you need to write id is equal to mu1. How you can identify the equation of the current when we will take the linear saturation or velocity saturation, w by L. In that case we need to change here the v mean. Okay, actually this expression will no need more. Okay, but I am writing here, no problem. VGS minus VTH minus V mean divided by 2. Okay, so the V mean value is this is the minimum of three things, that is VGS minus VTH, one is the VDS, and one is the VDS set. So we need to check which value is minimum. Okay, which value is minimum. On the basis of that, we will have the region of operation. If VGS minus VTH is minimum, then we need to take the current equation in the saturation region. If VDS is there, then if VDS is minimum only, then linear region. If VD sat is minimum, then we'll take the velocity saturation region. Is velocity saturation. Okay, I hope you understand like that. Okay, so the velocity of electron. So this is the complete about the velocity saturation, and this is the second short channel effect, that is the velocity saturation. Okay, if you want to again I'm explaining. Okay, the velocity, if we increase the VDS now, so the electric field will also increases across the channel. Okay, so electric field is increases, due to that the electron will get more and more velocity. Okay, and it will travel from source to drain. But after a some time, only we can apply 10 to the power 5 meter per second. This is the critical electric field. If electric field will go beyond of that, means VDS is increasing, if VDS is increasing, electric field is increasing. If electric field will go beyond that, then the velocity of electron will saturate it. That is the velocity. So this is the second short channel effect. So we will meet in the next video. Okay, I hope you understand. Thank you.